Good morning, everybody. So we are still in the first week of this new class where we're learning to write C# code, and this is our second lecture. And in our first lecture, we didn't really touch any code. We didn't write any C#, um, and so we learned to kind of work within Visual Studio as this new tool for writing C#. However, we didn't actually write any code. So this is that first lecture that we're going to learn the fundamentals, the foundation of a lot of working and writing in C#. And so this Prezi is called working with data. This is what we need to get into and start to write C#. Kind of the ground floor, if you will. And so we're going to get into a bunch of different pieces. The first of which is what are identifiers? What rules do they have to follow, and how do we come up with them? And so, introduction into this, working with data. The whole reason that we build applications are ultimately to work with information. So data is at the core of importance when it comes to applications and writing apps, so that we can take information from a user or from a database. Just take information, work with that information, maybe change it, do some math on it, and then output some relevant new information. Maybe that in the early days of computing, I think of this example. In the early days of computing, they were computers were just that, they would compute. And so in the early days of computing and the invention of computers, the whole purpose was to run some calculations. If you've ever seen, there was a popular movie called Hidden Figures, and in Hidden Figures, they had people doing these calculations. I keep getting emails, and this is going to have to stop because it's chiming at me. In this movie, which is based on real life, these people, which were called computers because that's what they were doing, they were computing trajectories of spaceship, re-entering orbit from orbit into the Earth, and how a spaceship would re-enter Earth depending on different variables, be it the wind and things of that nature, and the speed that they were traveling at. And so the early days of computing, that was what computers did. They just ran calculations. And the benefit, obviously, of a computer running calculations is it can do it a lot faster than a human can, and it can do it a lot more accurate. If you can teach a computer to do math, then it can do it faster and more accurately than a human can. And that was the purpose of the early day computers. That's why they're called computers, is that they would compute. And so, working with software, building software at the core of working with software, is working with data. So we have to be able to store information and manipulate that information. And the way that we do that are with these things called variables. And so on the slides here, you got identifiers, data types, and variables. Variables are ultimately what we put our data in. Okay? And so we're gonna create these things in our programs called variables that store information, and then we can manipulate those variables, to compute, equations to solve problems. In order to work with variables, again, variables are how we store information. That's how we store data. We're going to learn about these things called identifiers, and we're going to learn about data types. And so these are just the foundations, the ground floor of working with data which really means working with variables. In what is a variable? A variable has a data type and it has an identifier. So these are parts, identifiers and data types. These are parts of your variables. And then we can learn to do math on our data, which is the end here called expressions. And so, this is equivalent of, when you're learning a new language, you're learning all these different terms that represent something, so a variable is a new term, a data type is a new term, an identifier is a new term, and expressions are new terms when it comes to this. Okay. So an identifier, okay, so I almost want to start with this variable piece. I almost want to start here to just take a look at a variable. Okay, so let's just take a look at this slide. I'm jumping ahead. I'm going to go back. But this simple slide has a lot of information on it. But this line right here, where you see the word int sum equals 12, that's a line of C#. And so we've got a couple different pieces here. A variable has an identifier, which is the name of the variable. It's like, my name is Evan. That's my identifier. So we get to name our variables. In this case, we call it sum. We're going to go over what are the valid names. Okay? You could name me Evan. You can name me a lot of things. I think Elon Musk had, for one of his children, had some crazy name. So there are some valid identifiers, like valid names for our variables, but there are also invalid identifiers. And so Elon Musk, even though he could have a crazy name, it had to follow some set of rules. And so there are rules for our identifiers. So in yellow, we could see this is our identifier. This is the name of our variable. Okay. In blue here, in this light blue, I think the one pronounced Kyle is Musk's kid. It's pronounced Kyle, but how do you spell it? Because it's got some crazy spelling. I kind of forget the... Yeah, anyways. So this variable has a data type. Data type's in blue. So you can see this blue data type, and this is an int. Okay, we're going to go over, again, we're going to come back to identifiers. What are the valid identifiers? What are the valid data types? Now, what does an int mean? An int means that it's a whole number. Okay, a whole number meaning it has no decimal places. Yeah, there it is. Elon Musk's kid. Some crazy name. So in blue, the data type tells us a little bit about our variable. And in this case, this variable called sum can store a whole number. So we know a little bit about sum in that it does not hold a decimal place by looking at its data type. Then we have this equal sign, which they call the assignment operator, which basically puts the value of 12 into sum. 12 is the value or the piece of data that we're working with. Okay, so I just wanted to jump ahead a little bit to this slide just to show you the different pieces. Is that we're working with identifiers, we're working with data types, and we're working with data. The data itself is the number 12. Okay, these are the different pieces. Now let me just kind of back up to the beginning and go through this in order. So we're going to start with identifiers. Again, my identifier is a human being. My name is Evan Andreas Gudmestead. That's my identifier. So what is an identifier? What rules do they have to follow? And how do we come up with them? So that's what we're going to do. What is an identifier? Again, they just name your variables and it's a variety of things. We learned that a variable has an identifier, but there are other things that we'll get into, such as your methods. Methods also have identifiers. So the main things, and there are more. Variables have identifiers. Methods have identifiers. Classes are identifiers. But, for right now, just generically, a variety of things, because we haven't gotten into these things. We don't know what these things are. But we will talk about identifiers being used in variables. That's how we're talking about them today. They are created by the programmer to describe a thing. So as a human being, I got to name my child, okay? Which is kind of a funny thing. There's an old programming joke. It's like, I have a hard enough time naming my variables in my C# program. How in the world can I ever name a human being? Right? That's it's kind of like a ha, funny programmer joke. Like, if I can't even name my variables, how can I name a human being? A little internet joke there. But these are created by the programmers. These are names that we create to describe a thing. Now, it's really important to give these identifiers accurate descriptors for what they're holding. And so when we're naming a variable, you don't want to call, for example, in your math class you had variables called x. X is not really a good variable name. X is a really bad variable name because you don't know, what x actually is. Sum is a better identifier than x. X, I don't know what x is. Sum is some addition of numbers. That's what a sum is. You're adding numbers together. That's a sum. Even better descriptor could be sum of money. Well, now you know that you're adding someone's money together. So the more accurate your names can be, okay, is a better thing. Okay, so identifiers are names that we get to give to our variables, but you want to give them accurate names. X, as an example, is a bad name. So if I go ahead and I'll just pull up create a new project. This is going to be a council app. If you saw Friday, then you'll know what I'm doing here. We're going to put this inside of chapter 1. Okay, so we got a council app, or just what's called a command line app. And we saw this, right? This is a variable with an identifier of sum. Sum holds a value of 12. The data type is an int. So just by looking at this one line, there's a lot going on there. As far as new terms that we have to learn, variable, identifier, data type. Data type is int. Identifier is sum. Now, as I said, it could be sum of money. Well, now we know that we're adding some dollar amounts together. So this is just our identifier that we want to make it descriptive. Okay, now there are some rules around our identifiers right here. Okay, I can call this sum of money and that's legal, but what is not considered legal? What can we not name our variables? These are the names for our variables. What can we not name them? Well, you can start it with an @. That's considered legal. You could start it with an @. must be made of letters, numbers, and underscores. So let's see if I throw an exclamation point in here. You can see that's going to break. Okay, if I throw like a pound symbol here, what if I try and replace the at with a pound? Okay, that's illegal. Okay, so all these special characters, like if you hold down shift and press, you know, any one of your number keys, like an ampersand, like all of these are illegal characters. Okay, the only special character is an at, and let's see if I throw an at in the middle there. Nope, that doesn't work. So it can start with an at symbol, but it cannot be in the middle. Okay, so we're just learning the rules for our names. Like if I tried to use Elon Musk's child name in here, let's copy and paste that. That's really gonna break. Okay, so that would not work. That would not work for our identifier. So going through these rules again. So letters, numbers, and underscore. If I use a 1 instead of an L, you know, not that that's a good idea, but it works. Underscores. Okay, now you could see that I've got underscores. Now you might notice that I've got a green underscore here. That's you can kind of read there. The variable sum of dollars is assigned but never used. Okay, so that's kind of a warning, but we don't have to worry about the warnings. Well, all that means is that we never actually use this variable. Like, so you put some value inside of a variable, but you never use it. In other words, it's kind of just sitting there without purpose. Okay, in a real program we would use this, but I'm just doing a demonstration. Well, part of the problem with Elon Musk's child name is that it has spaces. Okay, so you cannot have spaces, and you can have a number like 1, but you can't start with a number. Okay, and it cannot be a keyword. For example, this word int is a keyword. There's another keyword called double, and that's a reserved word in C#. Okay, so those rules for identifiers are being that we're going to start working with data, we're going to start storing information. You know, you're going to start creating your own identifiers. As you create your own identifiers, you have to know what is a valid name for our variables. You know, it might be confusing if you try to put a number in the front of your identifier and you get an error and you're not sure why, right? So these are rules to follow. Now you're going to notice that when I did sum of money, okay, I started with the lowercase and then every new word I capitalized. Okay, the variable with an identifier of sum of money. This is a naming convention called Camel Casing. Okay, what people have done over time is that they've come up with naming conventions because it's pretty, how do I want to say this? So that your variables are uniform. Okay, so that you and I working together as a team, working on the same software, we can essentially merge our code and have the same naming convention for our variables. Another one would be underscore notation. I could do sum of money, and it's kind of hard to see there, but there are underscores. Okay, but in this class and quite common in the industry, they use Camel Casing. Okay, so that's what we're going to do for our variables. We're going to use Camel Casing, where you start with the lowercase. Every new word is capitalized. Okay, there's another one, like for example, if I were to do these are actually now two different variables that can store two different values. Okay, C# is case sensitive, and so sum of money like this and sum of money like that creates two different variables. This one here is called Camel Casing. This one here is called Pascal Casing. Okay. And so that's a different naming convention. You could use underscores, you can use Camel Casing, Pascal Casing. Those are common ones. In this class, for our variables, we will be using Camel Casing. Okay. Again, it's you want to be descriptive. You want to take the nouns and adjectives and combine them using Camel Casing. So for the total weight of the car, the noun, the person, place, or the thing is car. And then the adjective is your descriptor, right? So weight, car weight, is what you're doing. You're combining the noun and the adjective to create your identifier. Okay, so objectives. What is an identifier? So I'll try generally asking the chat room, what is an identifier? This is me asking my class. Not all at once. Don't hold back. All right, we got the answer. An identifier is a name for a variable, which is correct. What Drew said is also correct. Now, to expand on that, could you also name other things that we haven't really learned about these other things yet? An identifier could also be a name for other things. I guess I'll make that a statement instead of asking the question. So it's a name for a variable or some other things. What are the rules for our identifiers? Again, I'm asking my class. Go ahead and type it out in chat, or if you just want to talk it out in the voice channel, that's fine too. What are some of the rules? No special characters except what? There's one special character. You're not allowed to use keywords. Yes, you are allowed to hold down Shift and press 2, which gives you the @ symbol. Okay, at the beginning. That's good. No spaces. That's good. Can't start with a number. That's good. What is Camel Casing? Yep, cannot be a keyword. Also good. This is Camel Casing. Great example. The first word is all lowercase. Every new word is capitalized. We're going to use Camel Casing. How do we come up with our identifiers in a scenario? You can also use Pascal Casing. Yeah, Pascal Casing is fine. Not in this class. In this class, we're going to use Camel Casing. But Pascal Casing is a thing. So that's good to know. Good answer. How do we come up with our identifiers in this class? It's not even in this class. Just in general, you've got a scenario. Noun and adjective, put them together. So the noun is the person, place, or thing, and the adjective is the descriptor combined together. Awesome. We are learning on a Monday morning. Moving into data types. Okay, I'm going to jump ahead as I did before. I'm going to look at the common data types, and I'm going to focus your attention on this first column. If you see where my mouse is, byte, short, int, long, float, double, bool, char, string. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 9 new things to learn if you've never seen these data types before. Okay, these are 9 new data types. All right, I did have a data type before, and you see the data type came before the identifier. So, data type, they tell us a little bit about our variable. They tell us a little bit about our variables. And what I mean by a little bit is what kind of data does our variable store? Okay, so let me combine this. They tell us what kind of data our variables store. So let me kind of cut this. Data types tell us what kind of data our variables store. Sorry for the choppiness. I'm just putting this together. Okay, I'm trying to put this in, bring it down from the lecture into just common lingo. Okay, so what kind of data? What do you mean? What kind of data? Well, an int is a whole number. Okay, no decimal points. Okay, so if we have int sum of money. Like notice if I try to put a decimal point here, it's going to bark at me. This is not allowed. Okay, by the way, this red squiggly means that this will not run. This code will not run. Okay, that's called a compiler error, meaning it will not compile. But in short, this program wouldn't run if you did that. Okay, so an int is a whole number. So kind of coming back to our slides. Yeah, int is the same as integer. That is correct. Now, I said 1, 2, 3, 4, 5, 6, 7, 8, 9 things to learn. Okay, but a lot of them are similar, so it makes it easier to learn. And so if we take a look at this, byte, short, int, long, these 4 that are in black, they're all similar, right? So it makes it easier to learn because I said an int is a whole number. Well, so is a byte, so is a short, so is a long. Okay, these are all whole numbers. Okay, they all just vary a little bit. Okay, so how do they vary? Byte, short, int, long. Those are the 4. All store whole numbers. However, the range of values they can store is how they differ. Don't really need a however. The range of values. Okay, so what do I mean by that? Bytes are kind of easy to explain because let's just say byte age, and this is going to represent person's age. Well, a person, you know, realistically, if you think about how old a person can get, you know, they start off at 0, and they might live to be 100. I think the oldest person in the world, you know, probably a little bit older than 100. You know, if I'm guessing, the oldest person in the world's 120 years old. I don't know. Okay, that would be a valid way to store this variable person's age is in a byte, because the range of values are basically for a byte data types can store numbers between 0 and 255. You can see here the minimum value is 0. The maximum value is 255. Okay? Now, there's a reason why those are the numbers that can be stored. Okay? So if I'm taking a number like 300 and trying to store it in a byte, that's outside of the range of values. Okay, you can actually see cannot put value into a byte. Okay, so that gives us our red squiggly, which means this program will not run. So it has to be within range. The reason that this is the values, and this kind of gets a little deep into the math, into some math. You might have heard that a byte is 8 bits. You might have heard that before. Okay, a computer byte is 8 bits. If you do some binary math with 8 bits, you're going to find out that the largest number you can store with 8 bits is 255. And so you have to be able to convert binary numbers into, which is a binary is base 2 numbering system. You have to be able to convert from binary to decimal. Decimal are the numbers that we understand. The numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So decimal is our numbering system. Binary is what a computer understands. When you have 8 individual bits and you do some binary math and get that converted into decimal, that's your value of ranges. Okay, now I should update this chart. Because, okay, so a byte is a whole number. Remember I said that byte, short, ints, and longs are all whole numbers. Okay, but specifically the values 0 to 255. Okay, the next one is a short. Short is also a whole number. Let's say we want to store, I don't know, distance traveled is 30,000. Okay. Now, in decimal, keep in mind we put commas here. Notice what happens when we put commas in our numbers here. Okay, 30,000 in decimal you put a comma. In C#, we do not. Okay, we do not put we don't. If this were like a $sign, we're not doing that. Okay, we're just simply storing the number. Okay, short data types can store numbers between. Now you notice a byte was only positive. I'll go into that. It's only 0 to 255. And this is roughly negative 2,000 to positive 32,000. So there's a range, a low end of the range, a high end of the range. A byte is 8 bits. You'll notice that a short is 16 bits. Okay, so we can store store a wider range of numbers, but it takes up twice as much. And I didn't talk on this. It takes up twice as much RAM. Okay, now you might be familiar with your computer hardware. You might know very well what RAM is, or you might be completely unfamiliar, which is totally fine. RAM is a resource in your computer's hardware, okay, that every program that runs out of RAM. The execution of a software on a computer runs out of RAM. So the more programs you have running, the more RAM they take up. If you've ever opened up too many programs on your computer, you'll notice that your computer starts to run really slowly. Okay, that's because more and more programs occupy your RAM. It only has so much RAM to go around, and then it starts to run slow. So one of the easiest ways, one of the first places to make your computer run faster is try to make sure you have enough RAM. If you don't have enough RAM, I need to disable those notifications. I'll do that so that I stop getting those interferences. So the first question you might be wondering yourself, well, why not store, if I've got the number 100, which represents a person's age, why not store that in a short instead of a byte? Because a short could store the number 100, but so could a byte. Well, a byte takes up half the amount of storage of RAM than a short does. So that means that your software, you could think of it as more lightweight. Okay, it takes less computer resources to run. If you're using the most efficient data type possible, your software will be written more efficiently. Now, in today's world of computing, okay, that's why you might use a byte instead of a short. In today's world of computing, our computers are so incredibly powerful that this difference is not noticeable whatsoever. Okay, when it comes to performance, okay, I'm just giving you the information why you might choose to use a byte instead of a short. But when it comes to performance on today's computers, you're not going to notice the difference. Like your programs, if you're using all bytes instead of shorts, they're not going to run any faster. Okay, in theory, that's the idea, but in practice, our computers are powerful enough today. Now, where it does make a difference, okay, it does make a difference in devices that don't have a lot of RAM. Okay, I think of like small remotes and things like that, like remote controls and small household devices. It can make a difference, and it does make a difference in databases. When you start getting into your data types and databases, when you have lots of data that you're working with, these data types are important. So roughly, a short can store the numbers -32 to +32. Integer, lot bigger range on integers. You're going to see that numbers can definitely be too big. Okay, now if we look here, this is thousands. This is our thousands, millions, billion. That's 1 billion. That's 12 billion. Okay, so 12 billion is too large of a number to store in an int. So 1 billion is good, 2 billion is not good. So we get into somewhere between 1 billion. Now you might wonder, that number, this 2 billion is good. Let's see where the range breaks. Oh, did I lose a spot there? Oh, I lost a place. 1 billion's good. 2 billion's not good. Now the math for an int is ranges -2 to the 31st power and 2 to the 31st power -1. So this is just the range. You know, again, the important thing to take away here is that this is like, 30,000. This is in the billions of the range. Now you might wonder why this is only positives and this is a negative on the minimum value, and so this can be negatives and positives. You can see that a byte is unsigned, which means that all 8 bits are used for positive numbers. Shorts, ints, and longs are all signed. Oh, what is the meaning behind -1? Okay, so the -1, if this is 32,200, this would be 32,199. You lose the 1 because you have to account for 0, so 0 is counted as a positive number. So instead of this being 32,200, this is 32,199 because you have to account for 0. So that's the meaning for that's the math to calculate the range. We get negative numbers and positive numbers here because it's considered signed. Signed is where we take one of the bits. So we got 16 bits for a short. So again, if we go, a byte is 8 bits, a short is 16, so it takes up double the amount of RAM. An int takes up double the amount of RAM as a short, and a long takes up double the amount of RAM as an int. So a long takes up 64 bits, but one of those is for the sign. The sign is either negative or positive. If we use one bit that represents a negative, we can get a negative number. Okay, because these are signed numbers, we can have a range of negative and positive numbers. Okay, and so you can kind of see that an int goes into the billions range, and again, it's somewhere between 1 and 2 billion, negative and positive. The long data type, again, these are all whole numbers. The long data type is 2 to the 63rd power. Really large number, really big number. Again, I can kind of, if you understand, the math behind it, you can understand that, well, 2 to the 63rd power is a huge number, and again, it's meant for incredibly large numbers, bigger than the billions, much bigger than the billions. Okay. We've been lecturing for 45 minutes. I think it's a good time for a quick breather. So I'm going to pause. All right, so we left off talking about the whole numbers here. Now, another term that, we talked about, byte, short, int, long. Though these are all categorized. You might also come across the term integral, integral, integral. And all that means is a whole number. It's kind of similar to integer. Integer is a specific data type that has a range of values that it can store. Okay, integral, G-R-A-L, integral, if I'm pronouncing that correctly, simply means whole number. Okay, so these 4 are all integral data types, simply meaning they store whole numbers. Now, next down in the chart, you've got this dark gray, and there's 2 data types in there, floats and doubles. float is 32 bits, so it takes up the same amount of storage as an integer. So ints and floats are both 32 bits in storage, so they take up 32 bits of RAM. Okay, but floats can store decimal places. And so let's kind of come into here. Now, this is kind of a weird thing here. I can kind of explain this. You might just think that you can just put decimal, it doesn't matter what number you store here in the decimal. It could just be like that, okay? With floats, there's kind of a quirk. I'll call it a quirk in that you need to put an F there. So you got your data type on the left over here, but in order for this to not give you an error like you get here with the red squiggly, okay, you also have to identify the data type on the right-hand side. This is not normal. This is kind of a quirk, but it's worth noting with floats that you have to do that. Okay, and there is an explanation as to why. Float and decimal data types can store decimal places. You can see that, oops, I said decimal, but I should have said double. There is a decimal data type, but that's not listed under this common one. I should have said float and double data types. Okay, so here's a float, here's a double. You'll notice for the double that you do not need to put like a D over here. As to why there's a quirk here with the float, here's the explanation. So the quirk with the float is that on the equal sign, on the left, there's a left-hand side of the equal sign and a right-hand side of the equal sign. And the data types have to match on both sides. Okay, and when the Visual Studio, we'll just call it Visual Studio, when Visual Studio looks at this number, it sees a decimal number. And when Visual Studio looks at this number, you have two options. Visual Studio says, well, I have two options. I can either assign this to be a float or I can assign this number to be a decimal on the right-hand side. And Visual Studio, by default, looks at this number on line 38 and says, I think that's going to be a double. Well, so what you have then is you have a float on the left and assigning it equal to a double on the right. So again, remember our data types have to match on both sides. Okay, and so what you have to do is you have to say, no, in fact, I know that this is a float. So you have to tell Visual Studio. Now down here we have a double on the left and we have a double on the right. Again, Visual Studio looks at this number and assigns it a double, and so it's no problem. Okay. There's a little bit more to it, but that's how I feel about that. Yeah. So that's the reasoning why when you have a float. Now, okay, then what's the difference? We kind of go back to our thing here and we could see, okay, a double has twice the amount of storage than a float. And so here's how they differ. A float can store 7 digits of precision. Yeah, if we go back to JavaScript, if we remember in JavaScript, we were using var for everything. No, there are other ones that can store decimal numbers, Dylan. Like for example, the decimal data type. These are common ones. So let's go back to Drew's question or comment. In JavaScript, everything was var, and basically, languages with data types are considered strict. Languages without data types are considered loose. So JavaScript is considered a loosely typed language. C# is strict. Okay. Okay, we did. So in JavaScript, we did have a convert method, and that was when so JavaScript handles the typing for us. And so in JavaScript, we would say something like var num equals 12. Okay, and JavaScript would see this 12 and say, it's going to be an int. And so we would store it as a var, but JavaScript would store it as an int. And so there was data types kind of behind the language, if you will. When we had to convert data types in JavaScript is when the JavaScript interpreter would get that wrong. When JavaScript interpreter would not get it correct. And so there was a automatic converting between data types, and if it would be wrong, we would have to manually tell it what to do. Yeah, and so most developers prefer strict languages like C# over JavaScript. Okay, the fact that JavaScript is getting so popular, but it's a loosely typed language, that's probably the biggest downfall of JavaScript, is that it's a loosely typed language. And so JavaScript evolved into something called TypeScript. TypeScript is JavaScript, is strict JavaScript. And so there's a real momentum behind this thing called TypeScript, which gives data types to JavaScript. And so TypeScript is gaining popularity. And so kind of the pros of JavaScript being loose is that it's easier to learn. It's easier to learn a loose language than it is a strict language. Because let's be honest, we have an hour and a half lecture over all these data types. And so there's a lot of learning that needs to go on. It's easier to learn a loose language. But the con is that developers, they like being able to know a little bit about their variables by looking at their data type. And so generally speaking, developers prefer strict languages because it tells them information about what this variable can store. Terry says, what about repeating decimals? Eventually a decimal will have to get rounded. And so, if you get like 0.3 repeating, eventually that rounds or cuts off. And there's all sorts of ways that you can make sure that your math comes out to be correct. No. Once you declare your... Okay, good question. Yeah, and I'll come back to that question, Terry, about the spaces, about the 7 digits of precision. So Drew says, okay, so if I have int number, int your age, you could set your age equal to that, and then you can set your age equal to, well, let's just say you're 12. You're 12 at one point, and then you get older, and you can change your age later on. So the data type only is used one time, and then from that point, you can just reuse that variable. Okay, there's actually, there's two parts. Declaring a variable is when you give it a data type. This is when the space in RAM is reserved. So this is declaring a variable and then assigning a variable. Where you say your age equals 12. Assigning a variable means giving it a value. To Terry's question, the 7 digits of precision, that's before or after the decimal place. So it's going to take the most important decimals. And so we've got more than 7 numbers here. So it's going to take the first 3, or the first 4 here, and then the last 3 here. Okay, so you get the 7 most important decimals of precision. You would lose, or you would, this number, if you wanted to store the 2, 3, 4, you'd want to store it in a double. Okay, because this number would actually only store 7 digits of precision in a float. And it's the 7 most important digits. Okay, a double can store 15 digits of precision. Okay, that's before or after the decimal place. And so if you've got a large number of decimal points after the decimal that you want to keep, you're probably storing that in a double. Okay, so I believe I answered Drew's question. I believe I answered Terry's question. It'll just accept the most recent change to the variable, then yes. So if I output your age here, then it would say 12. And then I could update your age to 13. And if I were to output your age here, it would output 13. We just haven't shown how to output anything yet. Good questions. Awesome. So that's floats and doubles. Another data type is Bool, which Bool data types hold true or false. And so you could say Bool is Monday, true. Bool is Tuesday, false. Yeah, you could think of it as Boolean. Boolean are true or false values. So Bool represents Boolean values, true or false. Now you wind up using those in your code. Later on we'll use Boolean values quite often in this class. But for now, just recognize it as a data type, and this data type holds true or false. Char. My middle initial is an A. Now you'll notice it's a single character. I can't store 2 characters. It is a single character. You'll also notice that I use single quotes. Okay, so to store a char, you put single quotes, not double quotes. Okay, so if you have a single, now you could also say char, exit key equals A char is a single character that you type at the keyboard. It can be a special character, it can be a number, it can be a letter. Okay, it can be any character on recognizable by the keyboard. These are all symbols that your computer recognizes. And so basically any character or symbol. You guys hearing me okay? Testing 1, 2, 3. Okay. So that's a char. And finally, strings. Strings are really common. Strings are any combination of chars put together. So again, a char can be any individual character at the keyboard. A string is one or zero. Well, you could say zero or many characters. So you could have an empty string like this, just empty, open and closing quotes. You could have a one character string, or you could have many character. You'll notice that strings are just a combination of characters together. A char is a single character. A string is many characters all put together. Letters, numbers, special symbols, doesn't really matter. Special characters, doesn't matter. Okay, you can put anything in a string. Zero or many characters. Zero to many. Okay, and those are our data types. And so strings are really common because you could store string username, string password, okay, semicolon at the end. These are our data types. Data types are broken down to declaring on the left side of the equal sign and assigning a value on the right hand side. Yes, you can have spaces are fine in a string. Good question. Hopefully you guys have paid close attention because this is so foundational for everything that we're doing in this class. That is correct. Chars are single quotes. Strings are your double quotes. Very commonly, mistake, people will try and put double quotes around a char, and that will not work. Single quotes around a char. Behind every username and password that you sign into on the internet, they will store your password in a string and hopefully encrypt that password. When they store it in the database, they're going to take your password, store it in the database, hopefully they encrypt it. So it's just not stored in the database as plain text. Yeah, these common data types are not unique to C#. These common data types are found in many languages. So you learn them in C# for the first time, and then you'll see them over and over again and over and over again. Now, I kind of, even though I didn't, I went through signed numbers and unsigned numbers and a little bit of binary. I kind of, talked about our decimal base 10, a byte is 8 bits. I went through all this information. So I just focused on this one slide and kind of covered all this information. What is a character? What is a string? Yeah. Yeah. It's kind of fun. You can see all your, if you go to your character map, char map, like run char map. And you could type any one of these. They gives you, like, if you hold Alt 0195, you can get this funny A. And so if I go into, like here, I'm going to hold down Alt 0195, and it types my funny A down here. So all of these characters, now they also have a Unicode value, U00B3. So this char, you might also see this char. Notice this funny A is U00B3. You might do U00B3. And then if I do a console.write line, this is going to output the exit key. Debug, start without debugging, Control F5. I got it wrong. 00B3. Let's see what I did wrong here. Maybe a capital B. I'm not so familiar with my codes here, but there is another way of outputting chars using this Unicode value. Capital U as well. It doesn't like that. There's another way. I'm not good at getting them from the char map. There's something. I'll figure it out. Not important. We don't really use that, but there is just another way of outputting these characters. Yeah, I think so. That's not here or there. It's not super important. But I'm just saying you might see a char stored in a format like this, which is fine. A string takes up a variable length of RAM. Depending on the larger string means the more RAM it takes. Okay, so what are the built-in data types? Question, kind of the second bullet, list the built-in data types. Just output them on Discord for me. Let me just start with this. What are the data types that can store decimal numbers? Double and float. What's the one that can store any length of characters? Strings. What about a single character at the keyboard? A single character at the keyboard. Charmander, that's funny. Char. As a category, what are the data types that store whole numbers? What's the name of their category? Yeah, what's the category? What's the name of the category that stores whole numbers? Not signed. Integral. Integral. Integral is correct. Okay? Now, what are the integral data types? There's 4 of them. Byte. Short, int, long. Okay. As a category, decimal numbers have a category name as well. Okay, it's confusing because it's floating point numbers. floating point numbers are the categories, basically, that can store decimal numbers. Now, the floating point data types, are float and double. Okay, so integral is the category which has integers as part of it. Floating point data types include float and double. Okay, just the language here is all that I'm covering. Okay, recording still going good. That's an interesting observation, Drew. All right, we've already created variables. I've showed you how to create variables. We've broken it down into two parts: declaring the variable, which creates the space in RAM. By the way, okay. Declaring versus assigning. You can do both. Like this right here, int sum equals 12. This is both declaring and assigning on the same line. And then changing the value is also an assignment. After the first assignment, a variable is said to be initialized. A variable is initialized after its first assignment. So that's just a term there. Then we have constants. Yeah. That is reassigning is just like so the variable is declared when you give it a data type. It's initialized when you give it a value. But then you can reassign it later on. The initialization is the first time you give it a value, and any time after that it's just called an assignment. Yes, it does, Drew. Lost my train of thought. Let's go back to the PowerPoint here. Oh, constants. Now our variables have camel casing. Constants are things that you do not want to variable. So variables by their nature can vary. I mean, like your age going from 12 to 13, variables values can vary. I mean, that's the nature of a variable, is that their values can vary. A constant is something that you do not want to vary. A constant should, once you initialize a constant, it will always remain the same in your program. So, like the way to initialize a constant is just with the keyword const. Then you give it a data type, and then the convention here is all caps. So this is a variable that happens to be a constant, and this constant is the tax rate, and we all complain about taxes being too high. So I think I bring home about 2/3 of my paycheck. So they're taxing me at about a 33% tax rate. So tax rate is a variable, but more specifically, it's a variable that cannot change. Notice if I try and change tax rate later on, our politicians try and increase our taxes, and we're not going to let them. Okay, underscores are allowed, but it's in our convention that we don't, in our variables, we're not using them. Okay, and to separate, you could have this run together, but it's a little bit easier when you have every word separated with an underscore. Okay, so this is a constant. You will see this. Also notice you need to initialize your constants right away when you declare them. So you need to give your constants a value and initialize them when you declare them. So our convention, again, I'm just going to kind of repeat, our naming convention for our constants are all caps, and then every new word separated with an underscore. Okay, in this case, hours per day is always 24. It's never changing, so it makes it a good constant. Okay. Let's get some user input. This is what you will need for your labs. So if you're kind of dozing off, if you're getting sidetracked, it's time to refocus back in, because our labs will need to get user input from a console. Okay, so all that up top is really not relevant. So ask the user their name and age. Output that information. Okay, so what I'm going to do is I'm going to make a program that asks the user their name and age, and then I'm just going to output that information back to the user. So the way that we prompt the user we need to ask them in a console.writeLine, please enter your name. And if I run this, you can see, please enter your name. I did have that little exclamation point up there. Let me comment that out. Here I did a console writeLine. I'm just going to comment that out because I'm not using that anymore. So please enter your name. Question for the class is, if I'm going to store this in a variable, what kind of variable would you store name in? Yes, I would store that in a string. You'll notice the console.writeLine is how I prompt the user. Console.readLine is how I accept information from the user. So I'm going to have string first name equals, and I'll ask the user for their first name, console.readLine. Please enter your first name. My first name is Evan. It just says press any key to continue. We haven't done anything more than that. Okay. This is how we declare a variable called first name, and we initialize it with whatever the user types at the keyboard. So whatever the user types at the keyboard comes out of this console.readLine. That's a prompt for the end user. I'm going to show you one more time. This right here is prompting the end user to type their name. This comes from console.readline. Okay. So now I'm going to prompt the user, please enter your age. Semicolon at the end. It's case sensitive. Capital C on console, capital W, capital L. Okay, C# is case sensitive. Parentheses. And then inside of here, what data type goes in between the quotes like that? What am I typing in here? I'm typing what data type inside of a write line? Again, the answer is, yeah, it's the same. It's a string. So inside of here, I know that this is a string because it's in double quotes. I create the data type of string. The identifier is first name. I initialize it with whatever the user types at the keyboard. What data type could I store a user's age? Okay, let's store it in an int. And Drew kind of alluded to this. Now I have int user age equals console.readline. Do you see down there it says cannot implicitly convert a string to an int? Does everyone see that error message? Cannot implicitly convert a string to an int. Remember what I said. The data type on the left has to match the data type on the right. On the left, very clearly, we have an int. On the right, we're letting the user type whatever they want at the keyboard. So if the user can type whatever they want at the keyboard, what data type do you think that is on the right? On the right, again, it's allowing the user to type. So on the right, we have a string, correct. So we have an int on the left and a string on the right. Our data types do not match. And so we need to take this string and convert it to an int. Okay, now the way to do that, there's several ways to do this. I'm going to do int.parse. There are several ways to do this. No, there is no parse int. So that was the way to do it in JavaScript, but in C#, I'm just going to do int.parse. So it takes the data type. Parse is just a word for convert, right? Parse means convert. And I wrap the console.readline inside of an int.parse. Okay? Here's another one. Another way of doing this. The convert to int32. Okay, but I like int.parse. Int.parse. There's multiple ways of doing that. The point being is we're going to take this read line, which is a string, and we're going to convert it to an int. So we've got an int on the left and we've got an int on the right. Yeah, the convert method, so there's a convert class, convert to int32. 32-bit integer. All right. Now let's output their information. syntax, there's a lot of ways to output, but the first way that we learn is, by the way, write or write line. Okay, I guess we should start with that. A write does not cause a line break. A write line does cause a line break. So at the end of this, it's like hitting the enter key. I can demonstrate the difference between write and write line, but right now let's focus on outputting the information. So what the user is going to see is this symbol right here. These are called curly braces with the number 0. That's a placeholder that will output after this string the variable identifier that's in first name. So this 0 will output the value that's stored in first name. This is our second placeholder, which has the number of 1. 1 is a placeholder for the second identifier after the quotes. So these are just placeholders. Don't let them intimidate you. It's kind of like saying the user's first name, Bob, is 30 years old. Will be the output. So if I say Bob and I say 30, now the output is Bob is 30 years old. Any questions about this so far? You know, getting user input. There are, if I wanted to get a float, there's a, if I wanted user age to be like 12 and a half, I could say float.parse. And that would work just the same. Now this allows for the user to enter, I'm 12 and a half. Bob is 12.3. So int.parse, float.parse, double.parse, byte.parse, those all exist. Yeah, so what you could do here is Bob is that many years old, and then you could reuse his name here, Bob. And so you can reuse these placeholders. The 0 placeholder represents the first identifier in the write line. Yeah, there you go. So 0 will always be the placeholder for Bob, and 1 will always be the placeholder for user age. Okay? Before having these placeholders, you would have to use what was called string concatenation with a bunch of plus symbols and adding, the syntax was harder to code. This placeholder shortens the syntax, and they even have a better, how do you run the code? Debug, start without debugging. Or control F5. Now, a couple things here that I didn't cover. Let's ask the user, how many dollars do you have? Int dollars equals console.readline. Okay, so we've got an int on the left, we've got a string on the right. We need to convert int.parse. Yeah, Brandon's kind of showing you the concatenation method that I was referring to. What happens if you start with debugging? We're going to learn about breakpoints. And if you start with debugging, you'll learn to use these breakpoints in troubleshooting tools. So that's start with debugging, where you're actually trying to solve bugs in your code, which is helpful in troubleshooting. Okay, so what we've done is input and output, right? But I always, in my mind, it's always real simple. Like you go, one of my first jobs was at Dairy Queen. I was 14 years old, first job, Dairy Queen. I was a freshman in high school. And at Dairy Queen, car would drive up, place order, would input their order to me. My register would do some math. I would output the total to the customer. This is something that happened all the time, right? Input, the person would input what they wanted to me by telling me. I'd plug that into the register to do some math, and then I would output what they owed back to them. So if I simplify this, input, math, output. Okay, that's what we're going to be doing in these early stages of this class, like this first week at least, right? And this is all too common. Input, do some calculation, do something, and then output it. In this case, here's our input. All of this is input. Prompt the user for their information. We're getting input from the user. This is the output, but we kind of skipped a step, and more than likely, you're going to be doing some math with the user's input. If I wanted to convert the dollars to cents, I would take the dollars input that they gave me, multiply it by 100. So if I have $1, I have 100 cents. So there is math involved to solve these problems. And so cents is not something that the user input. Cents is something that my software is going to calculate. Bob is so many years old and has that many cents. And I'll get rid of the word Bob. Bob is that many years old and has... Now our program's a little bit more realistic. We get input, we do some math, and then we output. So Bob is 30 years old. He has $2. So Bob is 30 years old and has 200 cents. So we've declared a new variable. The data type is integer. The identifier is cents. And it is initialized with a value of dollars. Well, what is dollars? Dollars is whatever they typed on line 88. So dollars is dynamic. That dollars comes from the end user. And then we multiply it by 100 to get the number of cents. So cents is initialized with a value, given its first value to be the number of dollars times 100. Okay, so input, math, output. Think of it in that order. You simplify it that way. Input, get your input first. Then you're going to have some calculations, and then you're going to do some output. Now, another thing about these placeholders is that you could format them as currency. So, for example, if I put a :C, it's going to take this placeholder and format it as United States currency. And that's going to put dollars and cents. It's not going to make Bob is 30. So it doesn't really make sense because it doesn't make sense with an S, S-E-N-C-E, because it's not $200 cents. So we would not really format this as currency because it takes the number 200, and that's a whole number, so it makes it look like $200. Okay? But you can kind of see the benefit here of there's some formats that can kind of get your output looking more realistic. Okay, and currency is just one of them. I just wanted to show you how to format some number. Maybe I was going to multiply this man's money by by 100, whatever. I don't need to fill this example out, but I guess I will. So for what we'll say casino winner. So the casino winner takes the number of dollars they gambled and multiplied it by 100. And then Bob is 30 years old and won at the casino $200. So if Bob had a $4 bet, oh gosh. Bob is 30 and he bet $5 and turned it into $500. So these placeholders can have formats. Okay, and we'll dive into formats later. I just wanted to show you that because it was on the slideshow. And you can kind of see here. Another format is the F format, which means 2 decimal places. It has a fixed at 2 decimal places, fixed at 4 decimal places. So you can do some rounding here with your placeholders. That's getting this number to be formatted as currency. Whew. Okay, almost done. Going a little bit over time. Your expressions are your math, the equations that we're going to use. You can add, subtract, multiply, divide, and calculate the remainder. Okay, we've got these shorthand operators. We'll use these throughout the class. I'm not going to hit these hard right now. You could increment and decrement a value by 1 using plus, plus, and minus, minus. Again, these will be used throughout the class. I'm not going to hit too hard. We can compare numbers. We'll hit all that in the class. I think keeping the expressions kind of light right now is a good thing. Okay, especially after a 2-hour lecture at the start of this class. All right, folks. Any other questions? Good interaction today. I really enjoyed having some interaction with you guys. That was much better today, then at the end of last semester. We kind of seem to have some good engagement today, so I appreciate that. You guys have access to this Prezi that you can work with anytime. So I'm going to go ahead and stop the recording here.